Hi, everybody. Welcome to the Shiko Math Practice Lab and Algebra 2 lecture series. In this video, we're going to cover the lesson 1.10. And in this video, we're going to talk about how to solve absolute value inequalities. So in the lesson 1.9, we were talking about how to solve the inequalities in general. So this video, we're going to focus on how to solve the absolute value inequalities. Okay, so let me show you the worksheets we're going to use for these lessons here. Okay, I'm going to go to the worksheets and let me see, where is my worksheet? Okay, here's my worksheets. Okay, so this is the worksheet 1.10, we're going to solve the absolute value inequalities. So we have two exercise set. So this is the first set, and this is the second set. All right. So as always, I'm going to do the example, in the blue here, so you can follow my example, and then later you can try to practice, by yourselves here. Okay. All right, so now the first thing is here. Let me go back here, all right? So let's try, okay? So let's try to do it little reviews here. Okay, so like for the previous section, we talked about how do we break the absolute values, right? So in here, if we say absolute value x equal to a, so that's the equation. So we said when we try to solve the absolute values here, so we break it. So we always break like x equal to a, or x equal to what? Or x equal to negative a. So you always break to the a and the negative a. And now for the inequalities here. Okay, so two things we need to be careful here. So if I have absolute values, right? So this is, you can be some function of the a's. Okay, so in here you can say it's like an absolute value of the x. And if this is less than equal to, okay, so in here we need to be careful about the notations here. If this is less than equal to some value of the a's here, so this is the one we called, if it's less than equal to a, so this is the one we call the what? We call this the end. Okay, what we mean, that means we call this is the end inequality. So that means when you break this ones here, all right? So when you break this one, that means because it's end, that means x is going to be between the a and the negative a here. Remember, right? So like when we do the equations, absolute value equation, when we break it to the a and the negative a. So in here, so in the inequality, we do the same. So if it be very careful about these notations, right? So if it's x less than, so we call this is end inequality. That's how do you break the x is in between, all right? So if x here is greater than or equal to a here, okay, so let's be careful here. So that's this inequality. That means x is greater than a. So this is, we call this the OR inequality. Okay, so what is OR inequality means? This is just like we did in the previous couple lessons. So that means the way you break it, you still break the a and negative a's, right? But you break this is, you say x is greater than or equal to a, or x is less than equal to the negative a. All right, so you have to remember these two things, just like you need to remember when you do the absolute value equations, you break it into equal to a or equal to the negative a. So here you need to see this is and or, is and inequality or is or inequalities here. So also like for this ones here, right? So if you graph it, right? So if you graph it, that means, you center at here, right? So this is x is really is x equal. This one's here really is x minus 0 also. So you center at the 0. Then you go to the either end, the a units here. This is a, this is negative a. So that's what we mean here, right? That means is in here, from here to here. All right. So the same ways here for the greatness here. Okay, so for the greater than, basically they will tell you here, that means this is also, this is x minus 0, right? That means here is 0, so you still have equal distance, a and negative a, but it's greater than, right? So that means if you graph it, so here will be greater than is here, and greater than is here. All right. So then you might ask, you say, hey, how about if I have, let's take a look, if I have x minus 3, let's just take a look here, it's less than equal to 2. What's that means here? That means here, right? So that means if you graph it, right? So this is the 0, it's 1, 2, 3, 4, 5, 6. This is negative 1, negative 2, negative 3, and up. Okay, so in here. So that means the centers here, right? Okay, so because this is less than, so I know is and. So where is the center? So this is equal to 0. So what is x equal to? X equal to 3, right? So that means it's a center at 3. Then you go 2 units either side. So that means the center is here. You go 2 units. So you go in here and go back 2 units is in here. All right. So this is what these inequalities mean. So like if we go backward, right? So if they said, if the problem say, hey, I give you this, how do I find this absolute value? So basically, how do you find where is the center? Okay, so what you will do here, so you will say it's 1 plus 5 divided by 2, so its center is 3. So now you find the center is 3, then you will see how many units on each side, and then you find the 2 units on each side, right? So what is your, because this is and is inside, so then you know is this is x minus 3 less than equal to 2. Do you get that? Okay, so so like, if they give you a graph, you can go backward, right, to find what is your absolute value functions here, all right? So the key things here, you need to remember, right? So it's like when you break it, right? If it is and, you need to break it. It's just like we say, this is how you break it. Let me highlight here, right? So this is how you break it, right? If it's you have an or, this is how you break it. This is very, very important. If you remember those two, then I think you will be fine, just like when you solve the equation for the absolute value, right? So it's super, super important, right? So make sure you know about it, and it's very important to remember, so, right? Also, like the problems here, if they give you the solution set, then you will see how do you find the the absolute value functions. Right? So how do you find the absolute value inequality. All right, so you ready to try some problems? Let me try to give you one more, maybe I think one more examples here will be one more examples here. Let's see here. So here, let's see here. Okay, so let's see. Let me try to erase here. Okay, so let's try to do one more examples here. All right, so like in here, if I have a graph here, right? So if I have here, let's say here, this is 0, this is 1, 2, 3, 4, 5, 6, 7. Okay, so if my graph give me is like this, I say it's here to here, right? And here to here, right? So then I want to write an equation of inequality. As you can see, for these ones here, right? Because they go two ends, so I know my inequality will be what? Will be or, correct? All right, so be or, then I need to find where it is centered, right? So let's try to do this one more time. So how do where is the center? Okay, so center, I use the where it start, right? So it's 5 and 1. So it's say 5 plus 1 divided by 2, so it's 3. So I know here is where is my center. So center from here to here is how many units each side? 2 units each side, right? So now I can write it. I can say this is x minus 3 and the 2 units, because this is or, so it's greater than what? Greater than 2, right? So that's from a given graph. How do you write it out? Absolute value inequality. Okay, so now that's good. So let's go back to the problems here. Let's take a look how we're going to do our problems here, all right? Okay, so now let's take a look at the first ones here, right? So the first problems here, they said, let's try, okay, so let's try to write the equations here. Try to write the absolute value inequality for the following graph. Okay, so for here, so first things here, I see the inequalities in these two. So I know this is the end, right? Okay, so let's take a look at how do I find the center, right? So the centers here will be what? So this is 3 and the negative 3s, right? So you add 2 ends. So 3 plus negative 3 divided by 2, it's 0. So I know here's my center. So how many units each end? So it's 1, 2, 3. So it's 3 units each side, right? Okay, so now I can write it. So this will be x, right? Because this is inside, so it's less than, also include the endpoint, so it's less than equal to 3. Okay, now let's take a look at the other one. Let me use a different color, so because this is blue, this is blue, okay? So these ones here, because the inequalities go to two tails, so I know, so first things I know, this is or, correct? So I know this will be the or absolute value inequality. Okay, so now the first thing is here, let's try to find the center. Okay, so where is the center? Okay, so this one and this one. Oh, so this is a 2.5 plus negative 2.5 and divided by 2. Oh, it's 0 again. So this here is my center. All right, so after center, how many units? 1, 2, and 5, right? So I have a 2.5 units to each side. All right. Okay, now let's write the inequality. So that means this inequality is what? So it's x minus what? 0, right? So the 0, so minus 0, so you can just write it as x. Okay, so this is the over. So over has to be greater than, right? So greater than 2.5. I don't have an equal sign. Why I don't have an equal sign? It's because there's a circle here, right? So you can simplify this is just x is greater than 2.5. Okay, so this is how do we do, give the graph, you find the absolute values, all right? Okay, so now let's take a look here, right? Okay, so now let's take a look at how do we do these problems here. All right, so the problem number 1 here. Okay, so let's take a look here. Let me use the green color. Okay, so number 1. So this is x plus 5 less than 2. Remember what we do? So this is what type of the inequality is and, right? So this is and. Why? Because this one is less than, right? So if it's less than, it's and. So how do I break it? So I break it, so I say it's x plus 5 less than 2 and x plus 5 greater than negative 2, right? Remember the lecture we just did? Okay, so that's what happens here. So now you can solve it. So how do I solve it? Oh, now this just become the regular inequality. So I minus 5 minus 5. So I will have x is greater than, so less than negative 3 and greater than negative 7, right? So this is our solutions here, right? So now if you try to graph it, so there's 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3. So negative, so I have the negative 3 to negative 7, 1, 2, 3. So it's from here, 4, 5, 6, 7, right? So here, okay? So that's what is my inequality. Okay, so now let's take a look at the second problem here. The second problem here is x minus 8 absolute value greater than equal to 3. Oh, you see here, right? So this is greater than. So what type of inequalities we have? We have a or, right? Okay, so now let's try to break it. Like the one we know, so how do we break it? So you say x minus 8 greater than equal to 3 over x minus a less than equal to the negative 3, right? Remember when you do the absolute value, you break it, it's always a positive and negatives, right? Okay, so now here, this one's here, you add 3 both, add 8 both sides, so this one will give you x greater than 11. Then you add 8, so this one will give you x is what? It's less than what? 5, right? Less than equal to 5. Okay, so now let's see here, right? So if this is like if this is 0, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so because we have equal sign, so that's why my answers here, x greater than equal to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is here, right? Greater than is go to the right. And the less than equal to 5, 1, 2, 3, 4, 5 is here. All right, that's what is the, that's what is the answer for the number 2 here. Okay, so now let's take a look at number 3 here, right? Okay, so now let's take a look at the problem number 3. Okay, so let me give it more space here. All right, so number 3 here is 2x minus 2 less than 3. Okay, so here, let's use the green color. All right, so number 3 here is 2x minus 2. So number 3 here is 2x minus 2. And what do we try to do here? Less than equal to 3, right? 2x minus 2 less than equal to 3. oh, here is a minus. So I immediately know what happens here. This is end. So we have a 2x minus 2. If it's end, we do like this, right? Then you plus 2 both sides. And so you have this is less than equal to 5. And what happens here? So this is 2x, this is negative 1. So what happened to the x here? X will be 5 over 2 and negative what? Negative 1/2, right? Okay, so now let's try to graph it, okay? So let's try to graph this one's here. So the same things here, right? So this is 0, this is 1, 2, 3. This is negative 1, negative 2, negative 3. And it's in between with the equal sign. So it's negative 1/2 is here. 5 over 2 is here, right? Oh, where's my 1/2 goes? Disappeared. Okay, here, back here. So that's what is my solutions here. All right. Okay, now let's take a look the problem number 4 here, right? So let's take a look at problem number 4. Okay, so this is the number 4. So the number 4 tell me this is 3x plus 5 less than equal to negative 2. Okay, so you say, oh, this is end, I have to break it. No, you don't even need to do that. Why? Because here, this is less than negative 2. So I know the absolute value can never be less than negative 2, right? Because absolute value has to be always positive. So what do we say here? No solutions here, right? So you need to be careful, when you see those things, so don't just say, oh, this is end, and then try to break it. So watch it, right? Just like we did a similar problem when we try to solve the absolute value equations here, right? Okay, so now let's take a look here. Okay, so let's take a look at the next few problems here. All right. Okay, so let's take a look. Okay, so here, let's see here, number 5. So this is a 2x plus 2 minus 7 less than equal to negative 5, right? Okay, so remember, just like we did for the absolute equations, I want to move everything to the other side. So only the absolute value stayed on one side. So that's why I want to move this one. So I plus 7. So that's why on the left-hand side, I only have absolute values here, right? So it's less than equal to negative 5 plus 7 is what? It's 2, right? Now you see, oh, this is end. Now I can break. So you say this is a 2x plus 2 less than 2 greater than what? Negative 2, all right? And then you minus 2, minus 2, minus 2. So you got a negative 4 is 2x, 0. So then the x is between 0 and the what? Negative 2 here, right? Okay, very good. X is between 0 and negative 2. And now let me try to graph it. So basically, so this is 0, this is 1, 2. This is negative 1, negative 2, negative 3. So 0 and negative 2. So it's here and here. Because they have an equation, so it's a solid dot. Okay. So far, so good. Let's take a look at number 6 here. Okay, so for the number 6 here, right? Okay, so this is 3x minus 2 less than 1. All right, like we did before. So what are the first things we need to do? we need to move everything else to the other side. So we only want the absolute value on one side. So I need to get rid of this 2. So I plus 2. So this is the absolute value 3x minus 2 is less than what? It's less than 3. Then you see a less than sign, you say, yeah, it's and. So that's why you do like 3x minus 2 less than 3 and greater than negative 3, right? Then solve it. Plus 2 all the way. So this is negative 1, 3x and the 5, right? So what is your x value? You divide by 3, divided by 3. Right, so you will get x is what? X is 5/3 and negative 1/3, right? So if you graph it, so what is going to be? This is 0, this is 1, this is 1, 2. So this is negative 1, this is 1, 2. All right, so let's try to graph my solution. So greater than negative 1/3, so it's somewhere here, it's 1/3. Less than 5/3, so it's somewhere is here, right? So then this is my solution. Okay, so it's pretty straightforward, right? Okay, now let's take a look at the problem number 7 here. Okay, so the number 7 here, this is very, very interesting problems here, right? Okay, so the problem number 7 is showing you, so the x, absolute value x greater than x minus 1. Okay, so this is good because absolute value on one side, right? So, and this is also is what? This is greater than. So what type of the absolute value we have? We have over, right? Okay, so now let's try to solve it. So we know how to break it, right? So we'll say this is, okay, so let's see, we know how to break it, right? So we say x is greater than x minus 1 over x is less than negative x minus 1, right? That's what we said, always have a positive and negatives, right? Okay, so for this inequality, so x greater than x minus 1. All right, so let's try to solve for x minus x minus x. I have a 0 greater than, so because the minus x here, right? So minus x here and minus x here, so canceled, right? So I have a minus greater than negative 1. So you see here, you say, oh my gosh, this one's tell me 0 greater than negative 1. Is that true? Oh, yes, that's true, right? So 0 is less than negative 1. So for every x is true. So this means that x is all the real number. Right? Because when you put the x's in here, everything will be true, right? So that means the x going to be all the real numbers here. So that's my first part here, right? Okay, so now let me see that here. Let me try to see I can okay, let me try to see we can get a more space here. Okay, so okay, I guess oh yeah, we do get more space. So I do want to get more space so we can continue solving these problems here. Okay, good. All right, so now let's see here. So now for this inequality, x less than negative x minus 1. Okay, so first I use the distributive property. So it's negative x plus 1. All right, now I solve for x plus x both sides. So I have a 2x less than 1. So x is less than 1/2. All right, so this is, I have two things here. Okay, so now let's see what is the solution. Okay, so this is my real number. So this is 0, 1, 2, 3, da, da, da. This is negative 1, negative 2, negative 3, da, da, da. So from the first ones here, they say, hey, x is all the real number. Oh, that means it's everything here. Then the second one is here. It says x is less than 1/2. That means it's in here. But this is a part of the first ones, right? So when you say over, so what is the solution here? Because it's over, right? So it's here, right? So the solution here is x is a real number. Right? So that means that every number of the x's here does not matter what x is here. So for this inequality, right? So it's always true. So this is true for all the numbers here. So it's not just like any interval anymore, right? So this is kind of the like the similar, like what we did before. So it's the number 4 here. Number 4 is to say, hey, we cannot find any number is less than -2, right? So there's no solution. Then the number 7 telling you is, hey, number 7 telling you is what? Everything is the solution. All the real numbers are the solution for this inequality. Okay, so that's it. And I know, for the absolute value inequality, a lot of students very, very confused about these topics, right? So remember, right? So every time you see an absolute value, you always break it positive and negatives, right? So also remember the inequality, you have and or, right? That's very important also. That will help you to decide, it's like the two tails or in the middle, right? So if it's the end, like this is end, so your solution will be in the middle. If it's greater than, then that will be the two tails here, right? So of course, number 4, number 7 are some special cases here, all right? Okay, that's it. And that is our last lesson for the chapter 1 here. And so I hope you get a very good basic understanding about how to solve the system, the equations, how to solve the absolute value, especially, for the absolute value part. We have 2 lessons about the absolute value. It's super, super important, all right? Because you're going to use that concept a lot in your next level math class in the pre-cal or calculus here. Okay, so it's nice to talk to you, and I hope that you find this lesson is helpful. All right, so if you need if you have any requests or you have any questions, feel free to send an email to me. And my email address is located at the beginning of the introduction slide. Okay, so it's a nice talk to you, and we're looking forward to talk to you in the next chapters here. Okay, bye. Have a good day.